is our point for factoring. We're going to start with a little warm up on our exponent rules that we learned in our last section. As always, I would encourage you to write down the problem, try it, but hit pause right now while you write it down and try it, and then come back and see if you got the right answer. Also, just a reminder that note sheets are available on Schoology, so you can always print these out if you'd like and take notes right from there. All right, so we want to give everybody inside this to the 5th power. So we have x to the 15th, y to the negative 10th, z to the 5th, y to the 5th, z to the 20th. And then we need to start combining some of these things that are alike, and there's more than one way to do this. Matter of fact, before you distribute the 5th to everything, you could have combined things back here first. So you can do your order, your exponent operations in different orders and still get the right answer. So I next am going to subtract. So I don't have anything to subtract with the x, but the y's, I can take negative 10 minus 5, so I have y to the negative 15th. Same thing with the z's, subtract those, and I get y to the negative 15th also. Now if you remember, we don't want negative exponents, so those two that have a negative need to move. Remember, anything with a positive exponent stays exactly where it is, so x to the 15th isn't going to move, but y to the 15th, oops, I just saw that I wrote that one as a y. That one needs to be a z. Thank goodness for erasable pen. All right, and that z to the 15th needs to come down below also to get rid of that negative. And there are other ways, other steps you could go through, but you would get that same answer at the end. All right, so today we're going to talk about factoring. And there are lots of different components to factoring. We're going to start with greatest common factor, because anything that you're factoring, you should always look for a GCF first. So when we talk about GCF, we're talking about greatest common factor. What that means is we want to look at all the terms and see if there's anything common between all the terms that we can divide out. So if you look at the 6 and the 9, you can see that they are both divisible by 3. So 3 is part of the GCF, and we could divide that out. And then both of these have an x. So 3x would be our GCF. We'd put that on the outside, and then we would divide each term by 3x. So 6x squared divided by 3x, 6 divided by 3 is 2. X squared divided by x is x. Then we want to take 9x and divide it by 3x. So 9 divided by 3 is 3. X divided by x is 1. So we don't have to put that there. So 3x times 2x minus 3. All right, we want to do the same thing on number 2. Find a GCF. So what is common between both of those terms is what we're looking for. Go ahead and hit pause so that you can write it down, find the GCF, and go ahead and practice factoring it out. All right, hopefully you noticed that there was a negative leading coefficient. We do not like negative leading coefficient, so your GCF would include the negative, so that could be taken out. So we want to say negative 4x squared, because there's a negative 4 that goes into both of them, and then an x squared. Now when we divide it out, that leaves us with a 2x, and then 4 divided by negative 4 would be negative 1. So negative 4x squared, and then in parentheses 2x minus 1. This is going to be a real key for you to remember. Anytime your leading coefficient's negative, make sure you factor that out. All right, next type of factoring is factoring by grouping. This is always one of my favorite kinds. When we do factoring by grouping is when you have 4 terms. Is the most common time that we do grouping. So we have 1, 2, 3, 4 right here. So basically, what we're going to do is take these first 2 only. So we're going to ignore the second 2 and look for a GCF of the first 2. What's common between both of those? Well, a 2x squared. So if we take a 2x squared out of both of those terms, we have 2x plus 3 left. Now we're going to look at the next two only. What's common between both of those? Remember what we were talking about with the negative a minute ago? This has a negative leading coefficient, so you want to take out a negative 1. There's nothing else that's common. Once you take out that negative 1, we have a 2x plus 3 in the parentheses. Notice that our parentheses ended up being exactly the same. That means you've done it correctly. All right, so since those are the same, we now only have two terms. This first thing is all one term, and the second thing is all one term. But what's common between each term? Well, the 2x plus 3. So our 2x plus 3 is our new GCF, so we pull that out. What's left from our first term when you take out a 2x plus 3? Well, the 2x squared. What's left in our second term when you take out a 2x plus 3? A negative 1. And those two binomials are our final answer. So go ahead and give it a try on number 4. Write that down. Hit pause right now while you write it down. Give it a try by grouping and then come back and check. So hopefully you grouped these first two together and found that 3x squared was your GCF, leaving 3x plus 2 inside. The next two have a GCF of positive 5, leaving a 3x plus 2 inside. 3x plus 2 is our new GCF. It's in both of them, so we take out the 3x plus 2 and have 3x squared plus 5 left. All right, now moving on to another type of factoring. Factoring a trinomial. Trinomial means that there's 3 terms when the leading coefficient is 1. So this only works when it is 1. But what we want to do is we want to try to figure out what multiplies to get this constant value, what numbers multiply to get 8, and what numbers add to get 6. Now we can only do this when our leading coefficient is 1. So keep that in mind as we're going through this. All right, numbers that multiply to get 8. Well, this one might be obvious to you, but sometimes they're not. So I want you to get in the habit of going through the factors for each number. So for instance, I always start with 1. 1 and 8. Then I go to 2 and 4. Well, that's all the factors of 8. So do either one of those add to get a positive 6? Yes, they do. Now, technically, you could also have a negative 1 and a negative 8 and a negative 2 and a negative 4, but we don't have any negatives in our problem, so we don't need those negatives. So 2 and 4 are the ones that multiply to get 8 and add to get 6. So we can use those as our factors. X plus 2, x plus 4. Ta-da! All right, let's try it again. You want to find something that multiplies to get 18, adds to get negative 9. Notice the leading coefficient is 1. So we can do this trick on this one. So multiply to get 18, add to get a negative 9. Factors of 18. 1 and 18, 2 and 9, 3 and 6. All right, so if we add all those, 3 and 6 give us a positive 9, but we want a negative 9. So we have to be careful. That means we need a negative 3 and a negative 6. Those would give us a negative 9. All right, so since they meet the two qualifications, multiply to get 18, add to get negative 9, then we can say x minus 3, x minus 6. All right, now we're going to combine a couple ideas that we've talked about today. Number 7 is a trinomial, but you might notice that it has some more stuff going on than the previous two. That's because it has a GCF. So remember when we started today, we have to look and see if there's a GCF, you always want to look for that first. On number 6, we didn't have a GCF. Nothing was in common between any of the terms, so we didn't have to worry about it. But on number 7, the terms all have something in common, which is an x. Also, if you remember, we talked about we always want to remove a negative if it's in our leading coefficient. So we want to take out a negative x before we even start the process that we did up above. If we do that, we now have x squared plus 5x plus 14. So we take, oh, that is not true. If we take out a negative x, these would turn to subtraction signs. Gotta be careful about that. All right, so x squared minus 5x minus 14. So now we can proceed and do the same thing we were doing before. Find something that multiplies to get negative 14, adds to get negative 5. So let's say 1 and negative 14, 2 and negative 7, and then 3, 4, 5, none of those go in. So 2 and negative 7 happen to equal negative 5. So those work. So those are the 2 we want to use. So we have x plus 2 and x minus 7. It doesn't matter which order these parentheses go in. So if you wrote x minus 7 first, that's fine, and then x plus 2. And then we can't forget the GCF that we took out at the beginning. So we have to drop down that negative x as well. So we have negative x times x plus 2 times x minus 7. So always, always, always check for a GCF when you are factoring and take that out first.